difficult situation for the Alliance to salvage, cutting the lines of communication running from Poland through the Suwałki Gate to Lithuania with an attack from the Belarusian territory to Kaliningrad would completely cut off the Baltic states. Meanwhile, the Russians might now have 1,340 kilometers of NATO border and two armies, Swedish and Finnish, to take care of. Both have the most modern equipment with very high capabilities, much higher than, for example, Germany. In a potential attack on the Baltic states, a large northern front opens up for the Russians, which cannot be ignored when making war plans. St. Petersburg is only 200.
Alright, so spanning tree protocol prevents broadcast storms, which is what this definition actually is about. Broadcast storms and like endless looping, endless switch looping. So yeah, 169 is just an auto configuration IP address for Windows. This is because your wireless card is incapable that it's going to work with that as opposed to something legacy. Secure Gateway Management Protocol. I don't know what that actually stands for. Virtual PBX for proprietary organization, which public services and WAPE. PBX is telephony, so really that is the only option that makes any fucking sense. Christ. I mean, that's unicast because it's just you're one person connecting to something multiple people can connect to. It just comes from the channel. The channel's unicasting it to you.
We had a very far and wide-ranging interview about many topics. One of the things that he addressed in English, most of his remarks were in Ukrainian, which obviously we will translate. But one of the things he said in English had to do with what the CIA director just said yesterday, which was that the United States is on the lookout for any possible use born out of desperation by Putin of tactical or low-yield nuclear weapons. So here is what President Zelensky had to say to that.
The director of the CIA warned that he's worried Putin might use a tactical nuclear weapon in this fight. Are you worried?
Not only me. I think all over the world, all the countries have to be worried, because you know that it can be not real information, but it can be the truth. Because when they begin to speak about one or another battles, or involve enemies or nuclear weapons, or some chemical, issues, chemical weapons, they could be. I mean, they can. For them, life of the people is nothing. That's why we should think, not be afraid. I mean, not be afraid. Be ready.
So none of the older wireless protocols use channel bonding. So that's why the N is the correct answer. N or AC would use this. Yeah, that's another obvious one. So baseline for what the network does. Okay, so it's 1 to 7 question. Uses that anywhere, but yeah, it's a viewer. Well, I mean, the only Linux command, well, etool is one, but you're just checking your IP. That's the only valid option. Etool really wouldn't do that. Not with that modifier. For the life of me, no one is using IPv6. I don't really know why anyone is putting it on Xen. Nobody uses it. Nobody ever uses it. It's just there. Packet filtering firewall, because that's what it's doing. And examines every single packet that comes in. This one is obvious because ATM is asynchronous transfer, so that's inherent in the definition. Okay, IPv6 addresses are 128, we know that. So STP configuration ensures that a laptop connected to a switch cannot alter the path on the network. Designated port, meaning there's one management port. The BID, the root bridge, BPDU guard, BPDU filter, none of that has anything to do with that. The BID helps calculate the root bridge. BPDU guard prevents those BPDU messages from flooding everything, right? So that's how you prevent that. Let's go back over the questions here, see what I've got. I did have some that are iffy. Did I do the entire review already? Stupid cabling. Which I ignored because I'm never going to make another Ethernet cable in my life. Okay. Here we are. Okay. These are your power over Ethernet specifications and the difference in the wattage. AF is 15.4, AT is 25. Which you may find easy to recognize because the higher voltage one is at a different point in the alphabet. Later in the alphabet. Just now. You got your OSI reference model, transport session, presentation and application. What you'll see is your application is your user interface. Presentation determines how data is presented by the user. So ASCII, BMP, GIF, stuff like that is presentation layer stuff. I excluded the lower three layers because we all know it's cabling stuff, okay? Physical layer, right? Kind of, sort of. You'll see here the E1 and E3 optical carrier or optical carrier specifications. Those are for fiber optic cables. PRI, primary radio interface, ISDN, that has 24 D channels on 164 kilobytes per second D channel. So therefore it's represented by 23B plus D, right? 23B channels, 1D. QSBF. Quad small phone factor pluggable Wi-Fi route transceiver that is compared with 802.3 AV standard. Compatible is what that should read. Small form factor pluggable, that's smaller. Used for 1 gig connections, more ports per linear square inch. Also known as a small form factor pluggable GBIC. Your 66 block is differentiated from your 110 block by the fact that your 66 is used for RJ11, RJ45. Most of your crimp tools will have both available on the end. The 66 block is the smaller of the two. Circuit switching is a connection between two nodes being established before transmission of data, whereas packet switching breaks the data into packets. Packet versus circuit switched, of course. Carrier sense multiple access, carrier collision detection. Each node waits its turn before transmitting to avoid interference. Dedicated lines of WAN technology, so that's a cable or the telecom path that is continuously available and not shared. So, there you go. Virtual circuit is one that logically appears as a dedicated line but can be configured in many ways logically. SVC is a switched virtual circuit established between parties and terminated after use. RS-232 is DB9. So here I have a description of graphically what you would see with a fiber optic cable. So cladding surrounds the actual lasers in the fiber optic cable. A plastic buffer surrounds the cladding. Kevlar surrounds this to prevent stretching. So your single mode fiber is 8 to 10 microns. The core is 8 to 10 microns in diameter, and it carries light along a single path from one end to the other. It's used for longer runs. And you'll see repetition of this definition too. Multi-mode fiber is another type. It's used for shorter distance and works by bouncing multiple light signals off of a reflective surface, so that each of the multiple rays of light do not interact. Many pulses of light travel different angles, and the resulting range is a few kilometers. So in this case, the cladding surrounds the fibers and reflects the data back to the core. APC is an angle polish connector. This has a curved surface, but the end faces are placed at an angle to each other. This angle is set at 8 degrees by industry standards. APC connections are not as susceptible to signal loss. The most common single mode fiber connector is a 1.25 millimeter local connector. So this is your multi-mode fiber is not suitable for distance because it's so much larger and susceptible to all kinds of problems in comparison. And fiber transceivers can have both single or multi-mode fiber. LC, ST, and SC are fiber optic connectors. UPC connections are prone to bad reflection over time, so just there's going to be data loss. And the APC connectors are better. So those are your two types of connectors. Generally, a sheath surrounds coax cables. Below this is braided shielding and insulation. You can cut open your cable and check this. You can see it. You've probably seen it before. BNC is used with the RJ59. RJ6 often use F connectors. Has an impedance of 75 ohms and is used to deliver broadband cable internet service and cable TV. RG is for radio grade. RG59 has more attenuation than RG6, used for shorter connections. So your internal connections. Now, for instance, like fiber will be better suited as an ISP connection to the DMARC than RG6, which usually is used for cable modem connections. STP cables are better to eliminate crosstalk due to the inherent shielding, which limits EMI or electromagnetic interference. But they're more expensive than UTP cables used in most small home office settings. Again, here's the other definition of power over Ethernet, which needs to be placed with the other definition for consistency. TIA 568A, okay, white, green, green. These are your 1 through 8 wires, right? Brown, or light green. Alright, look at your TIA 568B. Straight through connections, commercial standard, white, orange, brown. Usually your questions are going to ask, where are these two like endpoints? Okay, light orange, white, green. Green for the A, orange for the B, brown for both. The only difference is the leading connector in point 1, the way I have it listed. Okay. Are we repeating the same crap about fiber optic? Am I crazy? Hold a minute. I don't know what's happening. Okay, we don't really need this long ass definition of media access. What fucking page are we on? My shit. Okay, we're on page 7 of 70. That's great. Most of the part of the review is Cisco commands I'm not going to use on the exam. I'm not taking the Cisco exam, I'm taking the easier one. Ethernet specifications basically will cover different media, including wireless. This is what you have to know really about all this. It defines communication, including frame format, frame size, timing, and encoding. Yada yada. Okay. I can tell you this was taken from Cisco material because of how detailed it is. There are your different bandwidths. 10 and 100 megabytes, 1 gigabyte, 10 gigabyte, 40 gigabytes, 100 gigabytes. Ethernet, this is important. Ethernet relies on 2 separate sublayers of data link layer to operate. Logical link control and MAC sublayers. Okay, so 10 gig connection is your Cat6. Max signal rate is 200 megahertz of bandwidth. It also includes a plastic core to reduce crosstalk. If you see Cat6A, Cat6A is augmented Cat6, doubles the bandwidth up to 500 megahertz for signal rate. Reduces attenuation and crosstalk. And you can exceed traditional network segments. Can reliably transmit data multi-gigabit per second data rates. Backward compatible, important. Down to Cat5. So, some of your crazy Cisco questions will expect you to know that. 1000 base T is an Ethernet standard for gigabit over UTP. One twisted pair. Okay, so again, carrier sense access, collision detection. Algorithm allows collisions to happen, but defines how the computers react. So if it was CA rather than CD, CA is collision avoidance. Collision avoidance wants to avoid the collision and doesn't really care how your computers react. CD wants to control that. Where have I seen this in review already? You'll notice a lot of repetition. That's because this is a Frankenstein document that was fitted together from basically Cisco V7 or V6, and then CCNA V7, which I just took. Your 2 ICDN books, which I've been up and down, and then my Network Plus material, including brain dumps and things like that. The brain dumps are just for the N Plus, meaning your question banks. So you're seeing a lot of repetition. That's because I've been over the concepts over, a couple of times. I need water. The Ethernet LLC sublayer handles the communication between the upper layers and lower layers. So this is... Alright, so LLC is implemented in software, and its implementation is independent of the hardware in a computer. The LLC can be considered the driver software for the NIC. The NIC driver is a program that interacts directly. Okay, you know what that is. We are finishing out the physical layer, right? And this isn't comprehensive because layer 2 gets confusing too because of the so many protocols that operate at layer 2 are also LAN protocols. SONET, MPLS, a couple others. I don't know why this VTP section is here. Throw this away. It's my crazy schedule on the right. Re-injured my ankle, so none of that's happening lately. Alright. So the LLC sublayer is above the MAC sublayer. So MAC is implemented by hardware, typically in the computer's NIC. So one second, something I'm confused on, which I shouldn't be. Yeah, these are data link rather than physical layer protocols. Okay, that's kind of what I thought. Ah, alright, so this is where X25 comes from. So X25 is packet switching. Alright, now I know. None of this about 3-tier campus LAN designs is on the Network Plus. All the extended Ethernet standards support cable lengths greater than 100 meters. I mean, that's in the wrong section technically. It needs to be over here with the cabling, probably like right there. Basically, there is, in the 3-tier campus LAN design, distribution, core, and access layers. Partial mesh topology between the access and distribution switches. It would link between distribution and core switches in the same manner, meaning that the access and distribution are connected, and distribution and core are connected, but they're not. The core and the access are not connected directly. So a switch forwards a frame destined for a known unicast MAC address by comparing the destination address to that MAC address table. It's a partial sentence. So a LAN switch forwarding a frame destined for a broadcast MAC address forwards it out all the interfaces in the same VLAN except for the incoming interface because it knows where it came from. Now an unknown unicast address, it forwards it out all interfaces in the same VLAN except for the same deal. Here's some of your Cisco commands. Same layer, adjacent layer interaction. Header information is added by the sending computer and processed by the same layer of the receiving computer. On a single computer, one layer provides service to the higher one. The software or hardware makes requests to the lower layer. When connecting to a Cisco device using console connection, one should use the parameters of 9600 bits per second, 8 data bits, and 1 stop bit. Now, I honestly do not remember why. Like, I'm trying to remember this because that is like semester 1 or something like that. That's I'm trying to remember what relevance that has because I've done it and I've never had to do that. Like where that's set in, I don't know. Adjacent layer interactions occur when a protocol at one layer makes a request to protocol at another. Okay. Switch learning means that the switch learns the source MAC address of the frame. If a switch receives a frame destined for an unknown MAC address, it is forwarded out all of the interfaces in the same VLAN, except for the one it received it from, as we've said. Okay. Carrier sense multiple access collision avoidance is used by wireless rather than CMSA CD, which is used by cell technologies. Okay. This is where it gets to be a mess again. Alright. Where do I move this? This is not the edited section. So we will edit. PAGP, I think is Cisco proprietary. Trunking. Oh, I'm wrong. SONET is layer 1. WAN operations need to be bolded. DWDM is not mentioned on N+. Packet switch techs are Metro Ethernet, MPLS, and ATM, and obviously X25. We now know. Never heard of X25 prior to my current employment. Alright, data is unpredictable because it can burst. Voice is not. Voice is always given priority on a network. Alright, that's just how you shape traffic. Right? Right in here with QoS. Point of presence is where you connect to a WAN. Obviously not a WAB is not a, that's a typo. PTSN and ISDN are circuit switch technologies. This is about the difference between the two, okay? Packet switching, continuous circuit switch, they turn it on, they turn it off. Alright, so when this is done, I must go to the hollowed location that is Dollar Tree. Alright. Quality of service. Propagation delay is the amount of time it takes for a frame to traverse the links between source and destination. Code delay is the fixed amount of time it takes to compress the data at the source before transmitting to the first device. QoS tools manage bandwidth delay or loss. DiffServ works on Cisco routers by classifying packets with the DSCO field, the 802.1q COS, or matching fields with an extended IP ACO. That's complicated. Priority scheduling is a behavior applied to low latency queue in a Cisco device. STP has a process similar to DHCP. You might be familiar with like knowledge and discover and all that. Alright, blocking and forwarding are the 802.1d port states used when STP has completed convergence. Listening and learning are the transitory port states used during the process of STP convergence. So actually listening and learning are first, blocking and forwarding are second. These should be arranged accordingly. Routers function at layer 3. Okay, these are like how to use VTP. Like, I get it. There's nothing to do with this. PBST is the default STP version, okay. Network address translation. Okay. Now this is one of the things that will make you want to open your desk drawer and pull out the 45 if you happen to have one in there. You know what I mean? And who you want to use it on at that point is up to you. Alright, so you basically have your inside local, inside global, outside local, outside global. At some point I will actually lab this out. I do have labs with this in it. I don't believe I've actually like gone through and like demonstrated. You know, it's a thing, okay? Alright, so your inside address is the one being translated by the NAT. Outside address is the destination. Local addresses are on the inside of the network. TACACS Plus supports the ability to authenticate different users to use different subsets of the CLI commands. I really don't know why that's here. Layer 2 and multi-layer switches can use DHCP swooping. Okay, we know this. IP addressing. This is where I have the trouble. And to be honest, I use subnet calculators, and I would just do this. God knows what I have in my bookmarks. Alright, so you see my ICDN books here. This is your connecting networks material. Some concepts: encrypted flash drives. That's pretty cool, right? Password crackers, blah blah blah. This cybersecurity stuff. I don't know why I have this crap. Get this out of here. CompTIA, StorageReview.com. That's for storage. I'll have to find an AWS question bank. Don't want to buy one. My book is from 2019, so that's going to be interesting. These are notable cybersecurity incidents. I do not have my subnet calculator still bookmarked, or my anything else. These are your Quizlet options. Nobody cares about that. Hulu's crap. LibriVox, definitely. Okay, so those are actually two of the most interesting cybersecurity incidents that ever happened. Alright, so what you want now, I've been having a good time arguing with people. Alright. Subnet. Pretty good example here. This is what you want to do. So we'll give you. Really, the exam does not give a fuck about what it is in hex. Okay. What is this? Oh, that's an easier version. That's actually like a really useful resource. Here's your CIDR. I'm just gonna go ahead and it has reserved ranges. I did not know this right here. RFC ones. Your wild card for your ACLs. I don't even know if I'm gonna have to do those. Bam. Simplistic, right? And your subnet calculators, like if you ever have to design a subnet, don't do it by hand. Very brutal. You can see I'm a multifaceted individual. I also do history. Ha ha ha. Alright. So I just wanted to pull those up. That doesn't make any sense. So different subnets are going to forward their packets to a default gateway, or if an IP address is a class B or a class C, is trying to like communicate with a class A. Alright, only 126 class A networks exist, starting digit of 1 to 126. The last 3 octets are empty, meaning you have a lot of space for hosting. Class B networks have a first octet value between 128 and 191, basically following right on from your class A. the routing process. So I don't know why that's there by itself. I probably had more than that, but FCS is frame check sequence field. It discards the old data link header and trailer, so it picks up. This is why this is here. A router picks up, and there's a different verbiage between frame and packet. Frame becomes a packet at layer 3. Okay, so router examines the frame check sequence field. It discards the old data link header and trailer, leaving the packet that it then uses, and it compares the destination IP to what it knows. Typically, a router will divide typically a router would. I don't know what the hell that's there for. It's not always true. Alright, one subnet should exist for a VLAN. Alright, so each of your switches, each of your VLANs. EO, Ethernet over MPLS. A point-to-point link local. Right? This is nice news, huh? I don't understand what Twitter's deal is with Musk. He just wants to buy it and make it all Wild West. Alright, so I hate the verbiage that they use for this crap. Class of interdomain routing, that's just the notation for this. Subtracting from 32 all the way down, right, until 16. Alright, we don't need to, where's the calculator? That's trash. Okay, this is better. You'll see how many addresses you'll generate. Okay, so why'd I say 16? It doesn't go, it goes all the way up to 1. Alright. Interesting. What is this here? Bogon? I don't know. Here you are with your private IP range. Your publics are going to fall in between those, obviously. You'll know the difference. Public addresses look different. Actually goes down to -8. -8's where Class A No? Huh. I was thinking Class B wasn't it? Yeah. That's the problem.